Hey there guys, Mr. Carlson here, and in this video what I want to do is I want to talk about, real quick, um, isotope notation, or in other words, how do we write different isotopes of elements, because I noticed that in your homework from last week, a lot of you guys, most of you guys did pretty good. There was a couple common mistakes, and specifically with how do we write different isotopes, because there's different ways that we can write that. And I noticed a lot of you guys were kind of messing that part up. So, first of all, um, let's just get one thing, let's review a couple things. So, first of all, um, each isotope, each isotope is identified with a mass number. So every isotope, if we're expected to write down an isotope, the way we identify a different isotope from another one is with the mass number. Okay, so even though there's different ways that we can write isotopes, you're going to see that each way that we write it, it has to include the mass of that isotope, because that's what's identifying that isotope. And also remember that when we're talking about the mass number of an element, the mass number is equal to the atomic number plus the number of neutrons. Okay, so these two things added together give us the mass of a specific isotope. And also remember that the atomic number is the how many protons you have. So essentially the mass of any isotope, when we're looking at the mass, all we're doing is we're counting up how many protons does it have and how many neutrons does it have. We add those two things together, that's the mass of the isotope. Okay? And so if we look at, for example, potassium, Potassium has actually three different isotopes. In other words, not all potassium atoms are exactly the same. Some potassium atoms have a mass of 39, so we would write that like this: potassium, put a little dash, 39. We also have potassium 40, and we have potassium 41. Okay, so these are the three naturally occurring isotopes of potassium: 39, 40, and 41. Okay, and remember again what that means is this isotope right here of potassium has 19 protons, and this one also has 19 protons. This one as well also has 19 protons. So again, how many protons you have, that's what determines what type of element you are. If you have 19 protons, you are potassium. If I were to change how many protons this has, I would change to a different element. So if I were to take one of these protons away, I wouldn't be potassium anymore. I would be, let's see, what is number 18 on the periodic table? Number 18 is argon. So if I were to take one of these protons away, I would become argon. If I were to add a proton and have 20 protons, I would become calcium. So the number of protons is what determines what element you are. But I can change the number of neutrons. I can change the number of neutrons that this has and still be potassium. And that's what these different isotopes are. These all have different numbers of neutrons. So this one right here, 19 protons, this one has 20 neutrons. 19 plus 20 gives me 39. This one over here, though, actually has one more neutron inside its nucleus than this one does. This one has 21 neutrons, and this isotope of potassium has 22 neutrons. Okay, so again, the differences between these has to do specifically with how many neutrons it has. And I can add or take away neutrons and still be potassium. I'm just a different isotope, or in other words, a different mass of potassium, essentially. The one thing, too, that I want to talk about is how there's different ways that we can write this. So this is one way that I can write an isotope. I can put the name of the element with a dash and then the mass. That's one way that we can write this. We could also just use the symbol, so I could just put the symbol for potassium, which is a K, and then again I can put the dash and then put the mass next to it. That's a perfectly fine way to do it as well. Also, like you saw on your homework, which I think this is where a lot of people were kind of getting confused, we will also see this written like this. So I could have this symbol written for it, and then what we'll see is a number up here in the corner like this. We can see this 39 up here in the upper left-hand corner next to the symbol, and that's just another way of writing it, just putting the symbol and then the mass up here. Another way we could see this written would be like this with the 39, and then we could also put the number of protons down here in this corner, so I could put a 19 right here. And I think that this one right here is what was kind of maybe confusing people. And I think the reason why is because if you look at the periodic table, so if we look at the periodic table, if I look at this, let's look at, here's potassium right here. So if I look at potassium, hold on, I gotta change. If I look at potassium right here, we see that it's got the mass on the bottom, 39.10 here, and then it's got the number of protons right here. So if I look on the periodic table, it's got protons on the top, mass on the bottom, but then over here we're telling you, okay, now when you write it like this, you got to put mass on the top and protons on the bottom. So it's like backwards from the way most periodic tables write it. And I know that's confusing. It's kind of stupid, but that's just the way it is. That's how we do the isotope notation. And then still, even another way that we will see this, which was a way that was on your homework, was I could have, whoops, I got to change this. I also have to erase this. We could see it, so with the symbol, mass, number of protons, and then we could also have a number over here, and it'll have either a plus sign or a minus sign with it. For potassium, it would be a positive sign. And we could have this 1 plus here, and depending on what element it is, that number can change. But we might see this number here, and this number up here is telling us the charge on the atom. The charge on the atom. So for this potassium, if I've got a 1 plus here, that means that this has lost an electron and now has an overall positive charge of 1. And you might be asking yourself, well, Self, how do I know if something has a charge? Well, let's take an example from your homework. Your homework, one of the questions was similar to this. It may have said like an element has 19 protons, 20 neutrons, and 18 electrons. And maybe the question will say, okay, they'll give you this. Write down what the symbol is, okay? Write down what the isotope is of what they're explaining. So all they say is 19 protons, 20 neutrons, and 18 electrons. Okay, well, I know that when I write this out, I've got my 19, which is the number of protons, and then 19 plus 20. 19 and 20 gives me the mass, and we write those like this. Now for the charge, remember the charge has to do with how many protons and electrons you have compared to each other. So if I have, in this case, I have 19 protons, which remember protons have a positive charge, and I have 18 electrons, which are negatively charged. So if I compare these two, I have more positive charge. I have 19 positive charges. So I've got a positive 19 with a negative 18. So 18 negative charges, 19 positive charges. I have an overall positive charge. And how much overall positive charge? If I were to add these two things together, right, I would be left over with positive 1 is what I'd be left over with, wouldn't I? And so that's the charge on this potassium ion, is what we would call it, because it has lost an electron. So if it was neutral, if this question said that it's a neutral atom of potassium, or it could say 19 electrons, then there'd be nothing here at all, because if I have 19 electrons and 19 protons, the charge balances out and the charge would be 0. But in this case, it's lost an electron, and so it has one more positive charge, one more proton than an electron, so it'll be plus 1 in that case. Let's do one more quick example, actually. So let's say the question says an element has, let me think, how about 8 protons, 8 protons, 8 neutrons, and 10 electrons, and figure out what isotope or ion that is, and then write out what the symbol would be for it. So take a few seconds. You can pause this, try and figure out what it would be. Write down the what the symbol would be. Okay. Let's go to the periodic table. It said that it's 8 protons. So I'm going to go find number 8. Hey, there it is right there. Let me change this. Here's number 8. It's oxygen. And here's the mass right here, which actually I'm not going to use that. Well, we are in this case because it's already rounded to 16. But all we would have to do for this one, right, is we're just going to add up 8 and 8, which works out to be 16 in this case. So I'm going to write O. I've got a mass of 16, 8 plus 8, and then number of protons is 8. And now let's look at, does it have a charge? And yes, it does, because it's got 8 protons and 10 electrons. So those are not the same. So I'm going to have an overall charge. I have to figure out what's the overall charge. Well, again, the electrons are the negative, protons are the positive. I have 2 more negative charges than positive charge. So my overall charge is going to be 2 minus. I've got 2 more negative charges than positive charge, so the overall charge is minus 2. So I hope that that helps when talking about isotopes, the different ways that we can write isotopes, how we figure out charge. Most of you guys, again, did fine on the homework. I just wanted to kind of review that a little bit for some of you guys that maybe were a little confused.